Alright, let's get into it. Number 8. The Hubble Tension. In the early 20th century, Edwin Hubble discovered that the universe is not static. It is expanding. This realization changed everything. It meant the cosmos had a beginning, and it will have an ending. For decades, the holy grail of cosmology has been to pin down exactly how fast this expansion is happening, a number known as the Hubble constant. If we know this number, we know the age of the universe, its composition, and its ultimate fate. But here's the thing, we broke it. Scientists have two primary ways to measure this number, and they are both incredibly precise. The first method looks at the baby picture of the universe, the cosmic microwave background, CMB, radiation, left over from just 380,000 years after the Big Bang. Using data from the Planck satellite, arguably the most perfect map of the early universe we have ever created, cosmologists predict the universe should be expanding at a rate of 67.4 kilometers per second per megaparsec. The error margin is tiny. The physics is solid. It is a prediction based on the standard model of cosmology, the most successful theory we have. The second method looks at the adult universe. Astronomers use standard candles, pulsating Cepheid stars, and Type 1a supernova to measure distances to nearby galaxies directly. It is a cosmic tape measure. When teams using the Hubble Space Telescope and now the James Webb Space Telescope calculate the expansion rate this way, they get a different number, 73 kilometers per second per megaparsec, 67 versus 73. To the layperson, this discrepancy sounds negligible. To a physicist, it is a catastrophe. These two numbers do not overlap. The statistical chance of this being a fluke is less than 1 in a million. Both teams have checked and rechecked their work for years. The instruments are working perfectly, the math is correct, and yet the answers are irreconcilable. This anomaly, known as the Hubble Tension, suggests something terrifying. Our understanding of the universe is fundamentally flawed. It implies that the standard model, the bedrock of modern physics, is missing a massive piece of the puzzle. It means that between the early universe and today, something happened. A mysterious force, a new type of particle, or a modification to gravity itself kicked in and accelerated the cosmos in a way we did not predict. Some theories are gaining traction, and they are, honestly, pretty unsettling. One suggests the existence of early dark energy, a temporary form of anti-gravity that flared up shortly after the Big Bang, cooked the universe, and then vanished without a trace, leaving only this scar on the expansion rate. Another suggests that we are living in a local void, a relatively empty bubble of the universe that is expanding faster than the outside, creating an optical illusion of speed. But the most disturbing implication is that the laws of physics themselves might be evolving. The constant g-gravity, or the speed of light c, might not be constant at all over cosmic timescales. We are building our house of knowledge on shifting sand. If we cannot reconcile these two numbers, we do not just lose the Hubble constant. We lose our grip on the history of reality itself. Number 7. The Impossible Galaxies of JWST. When NASA launched the James Webb Space Telescope, JWST, in 2021, the goal was to peer back into the cosmic dawn, the era just a few hundred million years after the Big Bang, to watch the very first galaxies form. The theoretical models were clear. In the early universe, matter was chaotic and hot. The first galaxies should have been small, messy, irregular blobs of gas, slowly clumping together over billions of years to form the majestic spirals we see today. That is what we expected. That is not what we found. Almost immediately, JWST beamed back images that sent a wave of panic through the astronomical community. It found galaxies, massive galaxies, galaxies that are too big, too bright, and too old to exist. Take the galaxy designated ZFA 19397. We are seeing it as it existed just 500 to 700 million years after the Big Bang. According to every simulation of cosmic evolution, a galaxy of this size should take billions of years to assemble. Yet there it sits, fully formed with a stellar mass comparable to our Milky Way, casually existing in an era where the universe should have been a toddler. This is not just a surprise, it is a paradox. These galaxies are being called universe breakers. For them to grow this large this quickly, they would have had to convert gas into stars at a rate of nearly 100% efficiency, something that is physically impossible. Stars blow gas away. They regulate their own growth. So, how do you explain the impossible? The debate is, well, pretty fierce. One camp argues that our calibration of redshift is wrong. That maybe, just maybe, we're misinterpreting the light and these galaxies are actually closer and younger than we think. But the spectroscopic confirmations are coming in, and they're holding up. The darker theory suggests that the seeds of these galaxies were not clouds of gas, but primordial black holes. If the early universe was flooded with massive black holes formed in the first second of the Big Bang, they could have acted as gravitational anchors, pulling matter together at impossible speeds. This would solve the math, but it introduces a new nightmare, a universe born filled with monsters. Or perhaps even worse, the universe is older than we think. Some fringe theorists are now dusting off the idea that the Big Bang was not the beginning, that the universe is cyclical, or that our age estimate of 13.8 billion years is a vast undercalculation. If these galaxies are real, the timeline of existence is broken. We're looking at adults in a nursery, and honestly, nobody knows where they came from. Number 6, Planet 9. Our solar system feels mapped. We've sent probes to Pluto. We've orbited Saturn. We've driven rovers on Mars. We teach children that there are 8 planets. But for the last decade, a ghostly anomaly has been haunting the data of planetary astronomers. Beyond the orbit of Neptune, in the freezing darkness of the Kuiper Belt, there are icy rocks, trans-Neptunian objects, or TNOs, that are behaving strangely. Sedna, 2012 VP-113, and a handful of others are all clustered together in space. Their orbits are elongated and tilted in the exact same weird direction. The probability of this happening by chance is about 0.07%. It is, honestly, statistically impossible. Something is out there. Something massive is herding these rocks like sheep. Konstantin Batygin and Mike Brown, the astronomers who, killed Pluto's planetary status, ran the simulations. The only thing that fits the data is a ghost planet, a world with a mass 5 to 10 times that of Earth, a super-Earth, or maybe a mini-Neptune, orbiting on a bizarre, highly elliptical path that takes it 20 times farther from the Sun than Neptune. 1 year on this planet would last nearly 20,000 Earth years. If it exists, Planet 9 is currently lurking in the aphelion of its orbit, the point farthest from the Sun, making it incredibly faint and hard to spot against the background stars. It would be a frozen, dark world, utterly alone in the void. But here is where, honestly, the debate gets terrifying. We've been looking for it for years. We haven't found it. This has led some physicists to propose a radical alternative. What if it is not a planet at all? What if the something warping the outer solar system is a primordial black hole? Not a stellar black hole formed from a dying star, but a tiny ancient singularity formed during the Big Bang. It would be the size of a grapefruit or a bowling ball, but with the mass of 5 Earths. It would be invisible to telescopes because it captures light. It would just be a sinkhole of gravity, silently orbiting our sun, passing through the outer dark. If this theory is true, we have a black hole in our own backyard. The debate is active. Telescopes are scanning the sky not just for a dim planet, but for the subtle flickering of background stars that would occur if a grapefruit-sized black hole passed in front of them. Gravitational microlensing. Until we find it, we are sharing our solar system with a massive invisible phantom that refuses to show its face. Number 5. The CMB Cold Spot. The cosmic microwave background CMBB is the afterglow of the Big Bang, a map of the temperature of the infant universe. It should be uniform. The temperature variations across the sky should be tiny and random like static on a TV screen, but they aren't. In the southern hemisphere of the cosmic map, there is a hole, a massive anomalous region known as the CMB Cold Spot. It is significantly larger and colder, about 70 microeler, than the standard model of physics can explain. The probability of a random fluctuation creating a spot this big and this cold is less than 2%. For years, scientists tried to explain it away. Maybe it was an error in the satellite data. Maybe it is a supervoid, a region of space billions of light years across that is unusually empty of galaxies. When light passes through a void, it loses energy, the integrated Sachs-Wolf effect, which could explain the cold temperature. But recent galaxy surveys have shown that while there is a void there, it is not empty enough or big enough to account for the full chill of the cold spot. The math does not add up. The void explanation is failing. This has opened the door to the wildest and most unsettling theory in cosmology, the multiverse collision. Laura Mersenne H., a theoretical physicist, proposed that our universe is not a solitary bubble. It is one of many in an infinite foam of universes. The cold spot, she argues, is a bruise. It is the impact site where another universe collided with ours during the chaotic expansion of the early cosmos. The implications are staggering. If this theory is correct, the cold spot is the first empirical evidence of the multiverse. We are looking at the scar left by a cosmic car crash on the grandest scale imaginable. It means reality is infinitely larger than our observable universe. It means there are other bubbles out there, other physical laws, other histories pressing up against our own. Skeptics argue this is speculative fiction, masquerading as science. They are desperately trying to find a mundane explanation within standard physics. But so far, the cold spot remains stubborn. It is a giant freezing anomaly staring back at us, hinting that we are just one bubble floating in a much darker, much more crowded ocean. Number 4. Fast radio bursts. FRB 121112. In 2007, astronomers discovered a new phenomenon, fast radio bursts, FRBs. These are millisecond-long blasts of radio energy from deep space. They are incomprehensibly powerful. In a fraction of a second, an FRB releases as much energy as our sun does in 80 years. For a long time, we thought they were cataclysms, one-off events like two neutron stars colliding or a black hole swallowing a star. Something explodes, releases a scream of radio waves, and is gone forever. Then Camera 121012. It did not stop, it repeated. Located in a dwarf galaxy 3 billion light-years away, this source kept firing, and not just randomly. In 2020, scientists noticed a pattern. It has a 157-day cycle. It fires actively for 90 days, then goes silent for 67 days, then starts again. This periodicity destroyed the cataclysm theories. You cannot blow up the same star twice. It has to be something that survives the event. The leading natural theory is a magnetar, a neutron star with a magnetic field 1 trillion times stronger than Earth's. Star quakes on the surface of a magnetar could release these flares. But the sheer regularity of the cycle is baffling. Is it in a binary orbit? Is it wobbling, processing like a spinning top? Even the magnetar theory struggles to explain the sheer focused intensity of the beam. This is where the debate enters the realm of techno-signatures. Avibe and other bold physicists have crunched the numbers on an artificial origin. If an advanced civilization wanted to propel a massive spacecraft across interstellar distances, they might use a light sail, a giant reflective sheet pushed by a focused beam of energy. The calculations show that a planet-sized radio transmitter, built to push a light sail, weighing millions of tons, would leak energy that looks exactly like an FRB. The beam would sweep across the sky as the planet rotates and orbits, creating the periodic cycle we see. ISRB 121012, a natural magnetic monster? Or are we hearing the leakage of an interstellar engine from a Type 2 civilization? The fact that we cannot rule out the latter is haunting. We are detecting a heartbeat across 3 billion years of darkness, and we do not know if it is a dead star or a living machine. Number 3. The antimatter asymmetry. This anomaly is existential. It questions why we are here at all. According to the standard model of particle physics, the Big Bang should have created equal amounts of matter and antimatter. For every proton, there should have been an antiroton. For every electron, a positron. Matter and antimatter are perfect opposites. When they touch, they annihilate instantly, turning back into pure energy. Gamma rays. If the theory is correct, the infant universe should have been a soup of instant annihilation. All the matter should have canceled out all the antimatter within the first fraction of a second. The result should have been a boring, empty universe filled with nothing but light. No stars, no galaxies, no us, but we are here. Somehow matter won. For every billion particles of antimatter, there were 1,000,000,001 particles of matter. When the Great Annihilation happened, that tiny fraction of leftover matter survived to build the entire visible universe. Why? This is the barren asymmetry problem. There is no known law of physics that favors matter over antimatter. We have been smashing particles at the Large Hadron Collider LHC for years, desperately looking for a violation of symmetry, CP violation, strong enough to explain this. We have found tiny discrepancies, but nothing close to the magnitude required to explain the universe's existence. Scientists are actively debating wild solutions. Some suggest that the antimatter did not disappear. It was separated. Maybe there are vast regions of the universe far beyond our view made entirely of anti-matter, whole anti-galaxies with anti-stars. If we ever tried to land a probe there, it would trigger an explosion larger than a supernova. Others propose that neutrinos, those ghostly particles that pass through us by the trillions, might be their own antiparticles, myonopermions, and played a trick on the early universe, converting antimatter into matter. But until we solve this, our very existence is an anomaly. We are the leftovers. We are the rounding error that survived the cosmic purge. The universe essentially tried to delete itself at birth, and we are the glitch that remained. Number 2. Oumuamua's acceleration. On October 19, 2017, the Pan-STARRS telescope in Hawaii spotted a faint point of light moving across the sky. It was not orbiting the sun. It was moving too fast. It came from interstellar space, plummeted toward our star, and then shot back out into the void. We named it Oumuamua, Hawaiian for scout. It was the first interstellar object humanity had ever detected. But as astronomers tracked its retreat, things got weird. As Oumuamua moved away from the sun, it accelerated. Now comets do this. As they heat up, they vent gas and dust, outgassing, which acts like a rocket thruster, giving them a push. But Oumuamua had no tail, no coma, no gas, no dust. Telescopes watched it with scrutiny, looking for any sign of evaporation. There was nothing. It was just a tumbling cigar-shaped or pancake-shaped rock, accelerating as if something was pushing it. This defiance of orbital mechanics ignited a firestorm in the scientific community that is still burning. The natural explanations are strained. Maybe it was a hydrogen iceberg, a chunk of frozen hydrogen that evaporates invisibly. But hydrogen ice is incredibly volatile. It should not have survived the journey between stars. Maybe it was a nitrogen iceberg chipped off an exoplanet like Pluto. Maybe it was a dust bunny, a super light fractal aggregate of dust. Then there is the hypothesis that no one wants to say out loud, but everyone is thinking about. Dr. Avi Low, the former chair of Harvard's astronomy department, put his reputation on the line. He argued that the simplest explanation for an object that accelerates without visible exhaust is solar radiation pressure. But for sunlight to push a rock that big, the object would have to be incredibly thin, less than a millimeter thick. Nature does not make huge ultra-thin sheets of material, but engineers do. Low suggests Oumuamua could be a light sail, defunct alien technology, space junk, or a probe drifting through the galaxy. Its tumbling motion, its shape, its spectral properties, and its non-gravitational acceleration all fit the profile of a manufactured object. The scientific community reacted with hostility. They want it to be a rock, but the data remains anomalous. Oumuamua is gone now, lost to the dark, moving too fast for us to ever catch. We missed our chance to know for sure. It passed through our system, behaved like a machine, and left us arguing in its wake. Was it a stone, or was it the first time we looked at a piece of garbage thrown out by a neighbor we did not know we had? Number 1, the vacuum catastrophe. This is the big one. This is the anomaly that keeps physicists awake at night. It is often called the worst theoretical prediction in the history of science. We are talking about the weight of nothing. According to quantum field theory, empty space is not empty. It is a bubbling brew of virtual particles popping in and out of existence. These fluctuations contain energy, and because mass and energy are equivalent (EMC squared), this vacuum energy should exert a gravitational pull. When cosmologists discovered in the late 90s that the universe is accelerating in its expansion, dark energy, they thought, aha, this vacuum energy is pushing the universe apart. So they sat down to calculate how much energy should be in the vacuum of space. They used their best quantum equations. Then, they looked at the actual rate of the universe's expansion to measure the observed energy density. They compared the two numbers. The theoretical prediction was larger than the observed reality by a factor of 10 to the 120th. That is a 1 with 120 zeros after it. To put that in perspective, there are only about 10 to the 80th atoms in the entire observable universe. The error is not just huge, it is incomprehensible. If the theoretical calculation were correct, the vacuum energy would be so strong that it would have ripped the universe apart in a microsecond after the Big Bang. No atoms could have formed. Space itself would have unraveled. Yet here we are. The vacuum energy is incredibly weak, just barely strong enough to push galaxies apart gently. Why is the prediction so wrong? This anomaly suggests that we fundamentally do not understand the nature of space. Some argue that there is a cancellation mechanism we do not know about, that some other force perfectly balances the vacuum energy to 120 decimal places, leaving just a tiny sliver behind. That level of fine-tuning is disturbing. It looks artificial. This leads to the anthropic principle argument. Maybe there are billions of universes with different vacuum energies, and most of them blew up instantly. We are in this one simply because it is the only one stable enough to support life capable of asking the question. Or perhaps the scariest option, our understanding of vacuum is an illusion. Maybe we are living in a simulation, and the parameters are set arbitrarily low to save processing power. Or maybe general relativity, our theory of gravity, breaks down completely at the quantum scale, and we are staring at the edge of human comprehension. The vacuum catastrophe stands as a monument to our ignorance. It is a giant, glaring sign that says, you know nothing. Until we solve this, everything we think we know about the universe is built on a foundation that does not make sense. The universe is expanding, accelerating, and hiding secrets in the dark. And the more we look, the more it seems that the laws of physics are just waiting to break. All right, we are done here.